To wrap up this section, we're going to revisit a couple of problems that we looked at from 2.4. We're just going to see how they're different, if at all, now that we have our power rule instead of using the four-step process. So we're going to be working with the function f of x equals x to the fourth minus 8x cubed plus 7. We'll start by finding the derivative f prime of x. Here, I can look at this, there's no roots, there's no powers of x in the denominator. I don't need to rewrite any of these terms, so I can just go ahead and use my power rule. F prime of x in this case will be 4x cubed minus 24x squared. The derivative of 7 then would be 0. So there's my derivative. Nothing more I need to do. Part B, here's the question that looks pretty familiar. It says, write the equation of the tangent line at x equals negative 2. So we're given that x value. We are going to have to find a y value, and we are going to have to find a slope. And once we find those two things, we should be able to write the equation of our tangent line. I'm going to start with the y value first, just because that's my preference. And if I want to find the y value, remember, I look at the original function. I'm looking at f of x in order to tell me the y value. And I'm going to plug in the x value that was given to me, which is negative 2. So f of negative 2, this is negative 2 to the fourth power minus 8 times negative 2 to the third plus 7. Let's see, negative 2 to the fourth, I should have 16 minus 8 times negative 8 plus 7. If we work that out, we should end up with a y value of 87. So my y value is 87. I still need to find the slope of my tangent line, though. And the slope of my tangent line is given by the derivative. Remember, that's kind of why we care so much about the derivative. So I'm going to take that same x value that was given to me, so that x equals negative 2, and we're going to plug that into our derivative. So the slope of our tangent line is equal to f prime of negative 2, 4 times negative 2 to the third power, minus 24 times negative 2 squared. So here I've got 4 times negative 8 minus 24 times positive 4. Be careful with your signs here. I should end up with a slope of negative 128. We're working with some large numbers here, I guess. So our slope is negative 128. We have our slope, we have our x value, we have our y value. We are all ready to go to write the equation of our tangent line. So I am going to use point slope form. That's, again, my preferred method of writing the equation of the tangent line. Y minus my y coordinate is 87, equals m, that's my slope, so negative 128, times x minus my x coordinate, which is negative 2. We'll take this equation and solve it for y. First of all, minus a negative, that's really plus a positive. The left-hand side will stay the same in this first step, y minus 87. On the right-hand side, we can go ahead and distribute. Negative 128 minus 128 times 2 should give me minus 256. Adding 87 over gives me y minus 87 equals negative 128x. Let's see, plus 87 should give me minus 169. Oops, I forgot my x value right here. But that is the slope of, that is the equation of the tangent line to our function at x equals negative 2. So once we have the derivative, this process should feel very familiar. Once we have the derivative, the process of finding the y value and finding the slope and then writing the equation of the tangent line, that didn't really change at all. It was just finding the derivative was made a whole lot easier because we have the power rule at our disposal now. The last question I want to ask here is to find the x values where f has a horizontal tangent line. Remember, a horizontal tangent line, if I have a horizontal line, I'm thinking about a flat line which has a slope of 0. So I'm thinking about a tangent line. The slope of the tangent line is given by the derivative, and I want the slope of that tangent line to be 0. So I'm taking my derivative and setting that equal to 0. So my derivative was 4x cubed minus 24x squared. So I have 4x cubed minus 24x squared. I'm going to set this equal to 0 and solve for x. I think the easiest way to solve this is by factoring. So I'm going to factor out, let's do 4x squared. That'll work out nicely. And that should leave me with x minus 6 is equal to 0. And then I can take each factor, set it equal to 0. So 4x squared equals 0, and x minus 6 equals 0. Just a little bit of algebra here. If I divide by 4, I'll end up with x squared equals 0, and then taking the square root, I should end up with x equals 0. On the right-hand side, if I just add 6, I'll end up with x equals 6. So that means I have a horizontal tangent line at x equals 0 and at x equals 6. So again, this process is really similar. If you go back and review these types of problems from 2.4, the process is exactly the same. It's only finding the derivative that's different, and it's much easier and much quicker in this section than it was last time around. The last thing that I want to remind you of before we wrap this section up is we now have f of x and we have f prime of x. And those tell us two very different things, and it can be easy to mix those up. So we want to make sure that we keep those straight in our head, and I want to just take a moment to emphasize the difference of those two things. If we're working with f of x, that tells us the y value of our function at a specific x value. So if you take 2 and plug it into your function, that's going to give you the y value of your function at 2. So the original function tells us the y value. The derivative, f prime of x, tells us the slope of the tangent line to the function f of x. I can say to the function 2 f of x, our function, at a specific x value. So if I take 2, plug it into my derivative, that will tell me the slope of the tangent line at x equals 2, not the y value. So these two look similar. We have f of x and f prime of x, but we need to keep them straight and remember exactly what piece of information each one of these gives us.